In this video, we're going to go over some graphing basics. I know you all are good graphers, but I just want to have you watch me do a graph, and we're going to talk about some elements of basic graphs so that when you do your graphs, they are all good. So here we go. New car owner kept a running total of how much gas was purchased during the first few weeks and the total distance traveled. Plot the graph below. And I'm just going to cross this out because that's what we want to know. So we have gas here, distance here. So let's just talk some basic vocabulary, right? This is our independent data because the researcher was choosing to talk about gas increments and then measuring as a result how many miles were traveled. So that is our dependent data. Anytime you have a set of data that's presented in a chart, we can make the assumption that the first column is the independent data and the second is the dependent. Remember, these are the things that the experimenter chose to manipulate and then was measuring how, as a result, what was going on over here. So this is the outcome of the experiment. And we're hoping there's a relationship between these. So I'm going to do some graphing, so if you'll notice, I'm using a pencil. I have a master's degree in physics, and I'm going to use a pencil. I do the crossword in pen, but I'm doing a graph, so I'm going to use a pencil. So when you graph by hand, use a pencil, because there's nothing worse than crossouts on a graph. So the first thing I want to do here, elements of a good graph, I'm going to put these over here. Of course, the element of a good graph is the title. First thing here, we want to have a title. In general, our title is going to be formatted as follows. Whatever's on the vertical versus whatever on the horizontal, right? Another way to say that is the vertical as a function of the horizontal. Now, this is a little different than maybe what you encountered in bio, but in the physical sciences, this is the accepted way of doing this. Now, generally speaking, what goes on the vertical, what goes on the horizontal axis, the independent data is going to go on the horizontal and the dependent data is going to go on the vertical, which is why it makes sense that the dependent data as a function of the independent data. That's the way we're going to phrase it. Now, there are going to be some graphs, just because I'm trying to manipulate the outcome, that I'm going to ask you to plot the dependent data on the horizontal. But I'll be explicit about that. But if I ever tell you, plot a graph of distance versus time, I'm telling you distance goes on the vertical and time goes on the horizontal, right? So this graph's title is going to be distance versus gas. And there we go. All right? So there you have it. And so that's going to be our norm for our title right there. Next, of course, we need to have our axes labeled with units. So let's plot that down here. So I'm going to put my gas in gallons here. I'm going to put it off to the side. I didn't really leave myself enough space here with my typing. We don't care about this stuff for the course of what we're talking about. And here, I'm just going to turn my paper to the side just for aesthetics. Distance in miles. Okay, so I've got my titles of my axes with units. Next, what I want to do is make my scale. So what's the element of good scale? The scale should do the following things. First, obviously have an even increment. Second, have a useful increment. Like, we don't want the scale to be such that all of my data is scrunched here, or that it's off to the side here. We don't want that. Another thing also is we don't want our tick marks to be weird numbers, like 13. Let's go up by 13.2s. No. What we want to do is use as much of the axis as possible while creating a rational increment. And we always have to start such that this is 0. No breaks in our graph. No breaks. Breaks are an atrocity. No breaks in our graph. Breaks are misleading. So looking here, I go from about 11 to about 52. Looking here, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. A little bit awkward there. Why don't we go up by, if I go up by tens, 10, 20, 30, 40, 50, 60. I'm using more than half. It's okay, it's not great. Maybe we go up by 8s. 8, 16, this will be 40, 48, and then 56. You know, we're not really getting that much nicer of a vision, because if I go by 5s, I'm going to go off the title here. I'm going to go up by 10s and just call it a day. Yeah, if we go actually, yeah, let's just go up by, or actually if I go up by, no, I'll go by 10s. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Now here's the thing, I'm using more than half the graph. That's our standard. Oh man, it's not as pretty as I want, but I'd rather have rational increments than perfect ones that use the entire graph. By the way, if you haven't figured it out, I specifically created the boxes on this so that we could have that discussion and talk about that evaluation. If you wanted to go up by 8s or 7s and extend it out, you can. It just gets a little awkward after a while. This one's a lot easier. This one we're going to go up by 10s because the top here, or by, not 10s, but by 100, because I've cooked it to make it pretty. There we go. Now notice here I didn't label everything. You don't have to label everything. There you go. So now let's plot our data. 11.5 there, boom, okay. 20.3, 420, okay. 33, 1, okay. 610, a little above. 45, just plop in the middle. 810, slightly above. 50, just here. So it's a shame I'm not using as much of the graph as I'd like, but there you go. So I've got my points down. And so here's what we're going to do. The next thing we're going to do here is we're going to circle these points. Why am I circling the points? I'm circling the points here because these points are experimental. We're going to circle every experimental point. Why? Well, very simply, actually, technically what you're supposed to do here is you're supposed to have things on your data points called error bars that show the level of uncertainty of the measurement. What my circles theoretically should be are ovals. Why ovals? Well, actually ellipses to be more precise. Because there's an uncertainty in the gas measurement and there's an uncertainty in the distance measurement. And the size of that oval, or the area of that oval, should be the area of uncertainty for that particular point. Now, that's so advanced that we're not going to do that for our purposes, but all we're going to do is show circles to show I understand this is experimental and has error involved in it. The last thing I want to do here before we talk about trend line is I want to ask the question 0, 0, question mark. Should I add 0, 0 to my graph? So that question is, if I were to do 0 of the independent, what would be the result of the dependent? Here, if I purchased 0 gas, how much distance would I be able to drive? Well, that car wouldn't be able to go anywhere. So if there was 0 gas in the car, I wouldn't go anywhere. I can add 0, 0 to this because logic dictates it. Now, here's the thing. Notice I'm not going to circle that because that was not an experimental point. It was a point that was gained through some sort of logic process. So next, best fit line, because this looks linear. If this looked like a curve, we would do a best fit curve. I'd sketch a curve in there. The important thing is if I'm doing best fit line, that I get a straight edge and I plot myself down a best fit line. So we should have as many points above as below. It should be about the average of the points. So there we go. You notice that one's a little above, that one's a little below, that one's kind of a bit above, but that might be our one that is least sure in terms of its error. And that's totally fine, right? To have things above and below the lines. We could actually talk about the error in this graph or the uncertainty in this point. I could calculate how far off the trend that was by measuring its deviation from the trend, and then talk about how significant that is by dividing it then by the value of the actual point, right? So I can talk about error in terms of graphs when we have points that are off of our trend. So that's kind of fun too. So there you go. basic ideas about how to make a graph. This is what your graphs should look like. They should have trends on them. The trends should be either smooth curves or straight lines using a straight edge. Do them in points. We talked about a titling convention. We talked about scale issues. We've talked about circling points. There you go.